Okay, here's another example we'll do together. We have 3 blocks all connected by ropes, and we're pulling to the right with 45 newtons of force. We're going to look at what happens when there's no friction first, and how it changes when there is a friction coefficient. So for this first one, again, we have to look at this thing as a whole system to begin with. And we're looking at, so instead of 45 newtons pulling 3 separate 5 kilogram objects, you can think of it as it's just pulling this 15 kilogram object with a force of 45 newtons. This is how we can think about it. Okay. And the reason why is when we look at this, we say, okay, there's this rope between these first 2 blocks. There's going to be a tension force and a tension force. Those 2 forces are going to be equal and opposite. I can call them T1 because we have a second rope right here. And this one, so the tension from the one side is going to equal the tension of the other because of Newton's third law. For every action, there's an equal and opposite reaction. Okay. Action, reaction, force. So when we actually write out our F equals ma equation, so we get all that mass, all that 15 kilograms is being accelerated. How much is being accelerated? We're going to solve that. So we have this applied force of 45.0 newtons. It's pulling it all. And then there's no friction. But what we can see is if we include all this tension, we see there's minus T1 plus T1 minus T2 plus T2. Or the reason why it's plus minus, if 45 is positive, this first T1 arrow is pointing the opposite direction. That's why I wrote down minus. The second T1 is in the right direction, in the positive direction. We're saying positive is right. That's why it's plus. This next tension is negative. Last one's positive. So you see, when we look at the whole system, all these tension forces cancel out. So all we're left with is 15.00 kilograms multiplied by some acceleration is equal to 45.0 newtons. Just take a calculator, 45 divided by 15, easy. Right there, we end up with 3.00 meters per second squared. So this whole system is going to accelerate at 3 meters per second squared. Now, if we want to find the tension inside between them, we need to look at the individual boxes. So we can either look at this part right here to solve for T1. Or you can look at, well, you actually can't use the middle one yet because notice if you look at the middle one, it has a T1 and a T2. So there's actually going to be 2 unknowns. We can't actually use the middle one. But we could do the last one, T2. So you're going to see there's some tension 2 is pulling this 5 kilogram block. So if we look at just T1 to begin with, so look at just T1. So we have this 5 kilogram block on the right. It's being pulled by 45.0 newtons, and it's being opposed by this T1. So what this T1 represents, it's pulling something. It's pulling this 10 kilograms worth of mass. Okay. So we write it out. We have this, if we call this block 1, block 2, and block 3. Here's block 1. So we have mass 1 is being accelerated by 3 meters per second squared. We've solved that already. It's being pulled to the right with 45 newtons, but it's being opposed by this T1, which represents the weight of the other 2 blocks. So when we solve this out, we have just the one unknown, T1. M1 is 5 kilograms, acceleration is 3. I'll write it out. So we have 5.00 kilograms. Acceleration is 3.00 meters per second squared. That's equal to 45.0 newtons minus T1. We solve for T1. That's equal to 30 newtons. Okay. So pulling these 2 5 kilogram blocks with an acceleration of 3 meters per second squared is equivalent, the same as if you're saying like some type of tug of war when one person's pulling 45, another person's pulling 30 for this 5 kilogram object. It's going to accelerate at 3 meters per second squared. Now we can look at block 2 because now that we know T1, we can use that 30 newtons to solve for T2, or we can just look at this last block. We'll just look at block 3. It's easier one. So block 3. We know it's being pulled with some T2 value. It's 5.00 kilograms. So mass 3 has the acceleration of 3 meters per second squared, and it's being pulled by T2. So you can just very easily solve for this. Mass is 5, acceleration is 3, 15.0 newtons. Again, we can check our answer by looking at the middle scenario if you wanted to. I'll let you try that out on your own if you want to, but actually I'll set it up for you. If we want to look at that middle block, the middle block is T1 and T2. This is block 2. So mass 2 is being accelerated and it's being pulled right by T1, but it's being held back by that T2. And should add up nicely.